energy profiles are diagrams which show the energy in a reaction. I'm going to draw a couple to show you example and show you how to label them. They're very straightforward. First of all, I'm going to label my X and Y axis, if I just get those drawn out. Okay, the Y-axis shows the energy for these diagrams. The X-axis shows the progress of the reaction. So sometimes you might see it labelled as time, or you might see it labelled as something like reaction progress, reaction coordinates, something like that. It just means it's going to show the reactants and then the products. That's all there is to it. So I'm going to start off by showing the energy level of the reactants. Let's draw those there. Let's label that this is the reactants that I'm showing here. Okay, two things happen in every chemical reaction. First process is you break bonds, and to break bonds you've got to put energy in to get it to break. So first thing we're going to show is the energy going up as we put energy in to break those bonds. Second process that happens is we're going to make new bonds, and when you make new bonds, bringing atoms together releases energy. So we're going to show the energy level going down now. Okay, I'm going to show it going to there on this diagram for this example. And now I'm going to show we've made our products. I'm going to show the level of the products there. Okay, to show the important things to label, I'm going to draw a dotted line coming from that reactants. There are two important things to label on every energy profile diagram. The first one is the energy required at the start to break those bonds and get the reaction going. This is called the activation energy, because it's the energy that's required to activate the reaction. The other really important thing to show is the energy from the reactants to the products. In this reaction, that is going up. So I'm going to draw an arrow that's pointing upwards. Now, if the energy is going up, the energy level, then that's because energy is being put in. So I'm going to write energy absorbed. Okay, what kind of reaction is this? Well, if we go back to this and we compare, the first thing, to break the bonds, energy going up, that is a bigger process than the second part where the energy is going down, where we're releasing energy. So we've got this kind of scenario where the energy going in to break bonds is more than the energy being released to make new bonds. So overall, energy is going in. So this is an endothermic reaction. Okay, I'm going to show you another example now to show you how an exothermic reaction is different. I'm just going to start with a little bit of information just so you can see the process of using these diagrams. So for this second one that I'm going to draw you, it's for a given reaction. I'm going to tell you what the reaction is. It's burning hydrogen, so the reaction of hydrogen and oxygen to make water. Now, we know before we start, because this is a combustion reaction, a reaction with oxygen, this is going to be exothermic, so we should be able to see that in our diagram. Same process at the start. Y-axis is going to show the energy, X-axis is going to show the time or the process of the progress of the reaction. And we'll start again on this level to show the reactants. The shape of the graph is going to be the same in terms of we are always going to start by breaking bonds, which requires us to put energy in to get them to break. So I'm going to draw the energy going up again at the start. Okay, I've got a little bit of information about this reaction, which I could have worked out myself about the bond energy, and that is that the energy required to break the bonds at the start is 1,370 kilojoules per mole, and the energy to the energy released when we make new bonds is 1,856 kilojoules per mole. Now, we don't normally show numbers on these reaction diagrams. It's just to illustrate and talk you through the process. This number's bigger, so the energy is going to go down further now than it did go up at the start. So I'm going to go down lower to show that. And the products are lower than the reactants now. Label the products. So the energy diagram is the same shape, it just goes down lower. And to label it, I do the same things. I'm just going to draw that dotted line from the reactants again. Activation energy always goes up, so I'm going to draw an arrow going up. Just for shorthand, I'll put AE. Activation energy. This time, from the reactants to the products, I've got to draw an arrow that goes down. So the energy is going out overall, so I'm not going to label this energy absorbed this time, I'm going to label it energy released. Or for either case, I might label that arrow as reaction energy, or something like that. Okay, so I can tell that this is exothermic because we've got this kind of situation going on now, where the energy required to be put in is smaller than the energy that's released when we make the new bonds. So overall energy is released. It's exothermic. We can also tell because our arrow shows that overall, to get from the reactants to the products, energy is going down, so energy is released. So that's an exothermic diagram. They're very similar. The way you label them is very similar. The only difference is that for endothermic, overall, it goes up to the products, whereas for exothermic, overall, it goes down to the products.